Well, hello Year 7s, and this is our last video tutorial, and we are looking here at exercise 11J, mass and temperature. Alright, let's get straight into this. I want to get this done, see if we can get through it pretty quick. Okay, the scales for both mass and temperature are based on the properties of water. Okay, so just try and take a second to think about that one. The scales for both mass and temperature are based on the properties of water. Okay, so water has had a big impact on mass and also temperature. Alright, so a bit of history. In France in 1795, the gram was defined as being the weight of 1 cubic centimetre of water, and we just did capacity in our last little video there, last little section. So the gram is defined as being the weight of 1 cubic centimetre of water at 0 degrees. However, later it was redefined to be the weight of 1 cubic centimetre of water at 4 degrees, as this was considered to be the temperature at which water is the most dense. Okay, and you've got to actually think about that. So depending on the temperature of the water, it can actually impact, or the temperature of the water can impact on how dense the water is. Alright, so they, bit of research, bit of science, found that at 4 degrees, that's where water is at most dense, so that's when they changed, so the gram now defined it as 1 cubic centimetre of water that is at 4 degrees Celsius. Alright, now, so 1 litre of water is very close, very, very close to 1 kilogram. So for every litre, so you pick up a litre of milk, that's basically 1 kilogram. Okay, very close to it. And this is the basic unit for mass. Other units for mass also include the tonne, the gram, the milligram. Okay, a small car has a mass of about 1 tonne, and a 20-cent coin has a mass of about 11 grams. Temperature tells us how hot or cold something is. Okay, we've done a lot of this stuff in science too. Okay, so this is sort of revisiting science in quite a bit, and I'll show you that very shortly. Anders Celsius from 1701 to 1744, a Swedish scientist, worked to define a scale for temperature. After his death, temperature was officially defined by degrees Celsius. Okay, after the guy who actually worked on defining a scale for temperature. Alright, so 0 degrees Celsius is the freezing point of water. 100 degrees Celsius is the boiling point of water. Okay, so you guys should maybe know that anyway already. Alright, a few notes and things you need to take and should take down into your workbooks, so you've got this to refer to in your workbooks. The basic unit for mass is the kilogram. Done that. 1 litre of water has a mass that is very close to 1 kilogram. Metric units of mass include 1 gram, milligrams, grams, kilogram, and tonne. Alright, so 1 gram is the same as 1,000 milligrams, 1,000 grams is a kilogram, 1,000 kilograms is a tonne. So again, a conversion little diagram, flowchart, table, whatever you want to call it. This needs to go into your books, definitely, 100% please. And again, also onto your help sheet, so you should have all your different conversions of length, conversions of volume or capacity, and also of mass, converting mass here. Okay, and very similar to our last one, where it's just whichever way you go from milligrams, either going from smaller to larger or larger to smaller, you're either multiplying by 1,000 or dividing by 1,000 each time. Okay, so again, pretty easy one to remember, but put that onto your help sheets. The common unit for temperature is degrees Celsius. Yes, Fahrenheit is also used, but this is the most common one. And as we said, 0 degrees is freezing point, 100 degrees Celsius is boiling point. Okay, a couple of quick examples, and this is this conversion. So convert to the units shown in brackets. We're going to go from kilograms to grams. So we've got 2.47 kilograms. We look at our conversion table. We want to go to, I've forgotten already, to grams. So kilograms to grams. Kilograms to grams. We're going this way. So we're going to multiply it by 1,000. So 2.47 multiplied by 1,000. I'm going to put G after it so I know that I'm converting it to grams. Okay, so I've got my 2.47 multiplying. So which way does my decimal point move? Yes, to the right. How many spots? 1, 2, 3. So here's my decimal point. 1, 2, 3 spots. There's my decimal point. 1 space. Put a 0 in there. So rewrite now, 70 with my decimal point in there and a 0 after it, because there is nothing, so it's got to be a 0. And I write grams. 2,470 grams. I think we can check that. Can I check that? There we go, 2,470 grams. I am correct. Okay, second example. We're going from 170,000 kilograms, and we're going into tons, into T for tons. So we're going kilograms into tons. We're going this way. So this time we're going to divide our number by 1,000. Okay, so we're going to divide this by 1,000 T. Okay, so equals underneath 170,000. Decimal point at the end, can't see it there, so decimal point must be at the end there. So I'm dividing it. Which way do I go? Yes, this time to the left. 3 decimal points. 1, 2, 3. So sitting in there now. So I'll rewrite it. 170.0. There's no other numbers there, so I'm just going to leave it as 0. And I'm looking at tons. So 170 tons. And let's have a quick look. I think I'm running out of battery here. 170 tons. Okay, or correct. Yeah, so that's it. All right, so conversions. Make sure you've got that. I could be running out of battery, so yeah, I've still got 22 minutes. Shouldn't be too bad. Yeah, so that's really important. Now, when you're looking through this particular exercise, there's a variety of different things that you might have to do. So, circle or write down which mass units are the same. Okay, so again, you're going to have to work on your conversions for that type of stuff. Which one would be the best match for the various objects with their masses. Think about temperature, so which item matches the best temperature best fit. What have we got here? Converting units, reading scales. We've done that a bit in science, so that shouldn't be any drama for you guys. Just quickly going over this, making sure there's nothing sort of tricky. Small truck delivers 0.06 tonne of stone for a garden. Write these as kilograms, grams and grams, so that's conversion. 20 blocks of cheese, each weigh 150. What is the approximate mass of the box? Yep, so you're going to have to work out each 150 grams, 20 blocks, multiply that, then convert it into kilograms. Yes, that shouldn't be too hard. Yeah, so temperature, drop in temperature, got to find the difference. Add all these measurements and give the result in kilograms. So obviously you've got to convert these guys into kilograms here and here. Same here, here, here and here. Convert them into kilograms and add them together because you've got to do the result, the answer in kilograms as it says there. Yeah, so all that should be pretty easy. All right, provided you've got yeah, this down pat for a start. All right, that's all we need to do. That's the last one. Been a pleasure. Obviously it won't be the last one because we're going on to a new unit after you do the test and do exceptionally well on that test because you have worked so hard and have prepared and done lots of revision and know everything really, really well, provided you've done all those things. If you haven't done all those things, you better get to it so you yeah, earn the mark that you get. Okay, and own the mark that you get. If you don't work, you're not going to get a great mark. If you work really hard, you will get rewarded and get good marks. Okay, all right, any questions, make sure you come and see me. That is all. Good luck and see you on the flip side. Bye-bye.